Okay, in this video, we are going to be talking about linear inequalities. So some things to remember about linear inequalities is that when you are adding or subtracting, with inequalities, do not change the sign. So you are going to solve this as it were a just normal equation. When you multiply or dividing an inequality by a positive number, don't change the sign. And you're going to solve it just like a normal equation again. But when you multiply or divide an inequality by a negative number, then you are going to flip the sign. And I'll show you an example of that here in a second. Okay. So when solving for an inequality, when you do this, it is just like solving for a variable that we've done in the past already. The only thing is when you run into this situation where you multiply or divide by that negative number, then you're going to flip the sign. Otherwise, everything is the same. So I would start here by adding 10 to both sides. So 6x is greater than or equal to 42. Then divide by 6. So x is greater than or equal to 7. So I divided by a positive number, which means that I didn't do anything to the sign. Okay, and I'll go over what these are for in a minute. Okay, so again, first thing that I'm going to do is add or subtract, in this case add. That's 42. So here's that case where we are dividing by a negative. So you are going to need to flip that sign. And that is negative 10.5. So when you flip it, right now it is open towards the right. This time now we're going to have it open towards the left. Then again, add 2 to both sides. So that we've got 3/5 x is greater than 9. Then we are going to multiply both sides by 5. And divide by 3. Okay. So these are just to graph those. So when we graph these, we're going to want to put 0 on here. And then this is our positive direction and then our negative direction. So you can go up by ones, but they probably won't fit. So if I go up by 2, so this is 2, then 4, 6, 8. If I do the same thing, so -2, -4, -6, -8. So this right here is 6. So 7 is going to be in between those. So you're going to put a dot on your line. Now, because our line, our inequality has this line under it, that means that it also includes that number. So it is less than or equal to that number. Or sorry, greater than or equal to that number. So I'm going to color that in. So, and then wherever your inequality is pointing, that's which way that you are going to shade on your number line. So if you've got a less than or greater than or equal to, or less than or equal to, that means that you are going to have a filled in dot. If you have just a greater than or less than, you are going to have a open dot. Okay, so if I put 0 on here, let's go up by 5. So 5, 10, 15, 20, -5, -10, -15, -20. So this one is -10.5, so that's going to be about right here. And our inequality does not have a line under it, so I'm going to leave that open. And it is pointing towards the right, so I'm going to shade towards the right. So I'm going to use the same number, so 5, 10, 15, 20, -5, -10, -15, -20. So it's 15, which is right here. And there's no line underneath, so I need to leave that open. And it's pointing towards the right, so I'm going to shade towards the right. Okay. Okay, so here we are going to write the equation and then solve for it. So let's go through and let's find our clues. So we've got 7 minus, so our subtraction sign, 2 times, so that's multiply, a number, which is our variable, so we'll say x, is less than, so less than is the less than sign, 3 times the number, so our x, plus 32. So we basically just wrote it out just a little bit longer here. So if we rewrite that, 7 minus the 2 times, so 2x, is less than 3 times, so 3x, plus 32. So there's our equation, and now we need to solve this. So I am going to start by putting all of the x's on one side of the equation, or our inequality, sorry. Then add 32, or sorry, subtract 32. So that's negative 25 is less than 5x. So now I just subtracted 32. I didn't divide by 32, so my sign didn't flip. So negative 5 is less than x. So this would be accepted, but you usually want x on the left side of your equation or your inequality. So x, and just to make sure that we do this right, so see how it's open towards the x right now? It needs to stay open towards the x. It's greater than negative 5. Okay. So some things to remember when graphing linear inequalities is make sure all the inequalities are in slope, intercept form, which is your y equals mx plus b before you graph them. If your sign is a greater than or less than sign, so not equal to, then your line is going to be dashed. So just like how it was an open circle on our number line, it's going to be dashed when you graph these. Then if the inequality is less than or equal to or greater than or equal to, then it's going to be a solid line. So just like how it was a solid dot. All of the graphs need some sort of shading. So to do that, you need to test a point. Usually that point is the 0, 0. But you can't use 0, 0 if it's on the line. So that would be the only time that you wouldn't use 0, 0. To see which side of the line that you're going to shade. And this will make more sense in a minute. So when you do test this point, if it's true, then you're going to shade to cover your test point. And if it's false, you're going to shade on the side of the line that the test point is not located. Okay, so let's go through a couple examples because this will make more sense. So x is less than or equal to negative 1. So first I always go through and I put if it's going to be solid or dashed. Now because there is a line under this, it's going to be a solid. Okay, so now I'm going to go ahead and graph this. And we should already know how to graph points from earlier in this unit. So the -1 on our x-axis, so x and y, is right here. So we need a solid line up and down through that point. So far seems pretty normal from what we've already been doing. So now we need to test a point. So we are going to test 0, 0. And you're going to want to put an X over your testing point. And we can use 0, 0 because it's not, our line is not going through that point. So when we test this, here's our X and here's our Y. So we're going to plug this into our equation. Now we don't have a Y in this, so we don't really need to worry about this one. But we do have a 0. So we will put this in for X. So 0 is less than or equal to -1. Now, is that true? Is 0 less than -1? No, it is not. So this is false. So if it's false, we're going to shade on the side of the line that our point is not located. So that's why we want to put our X there. So we shade on the opposite side of that. So we're going to shade over here. Okay. Let's go on to the next one. Now I'm going to have to rewrite this at the top because it's on the bottom over here. So 1/2 X, 1/2 X plus is less than Y. Okay. So first thing let's do is let's say if this is solid or dashed. Now this one does not have a line underneath it, so it is dashed. Okay. Then this is already in slope intercept form. So we would say what our M and our B value are. So the M value is 1/2 and our B is 3. So I'm going to start at 3, and from there I'm going to go up 1 and over 2, up 1 and over 2, all the way across my graph. So again, no different than what we were already doing. Now this one is dashed, so you don't want to connect all of these points. You just want to make it look dashed. So something like that, and then make sure that you've got arrows on either side of your graph. Okay, so now we need our test point. So 0, 0 is not on our line, so we can test that. So this is my X value and this is my Y. So 1/2 times 0 plus 3 is less than 0. So all I did was I took the x and the y and plugged them in for x and y into my equation. So anything times 0 is 0, so this is just going to cancel out. So 3 is less than 0. So that is false. So again, I'm going to shade on the side of the line that doesn't cover the test point. Okay. And last one. So this one is not in slope-intercept form. So first thing that we need to do is get this in the proper format. So I'm just going to rewrite it over here so that gives me some more room. So our slope-intercept is that y equals mx plus b, so we need to get y all by itself. So I'm going to do that by subtracting x on both sides. So negative 2y is less than or equal to negative x plus 5. And then I am going to divide by negative 2. I need to divide everything by negative 2. And because I divided by a negative, I need to flip my sign. So, and then there's that imaginary 1 right here. And the two negatives make a positive, so that's 1/2 x minus, and that's minus because this becomes a negative, so 5 divided by negative 2 is negative, so the minus 2.5. So this is going to be a solid line. The m value is 1/2, and our b value is negative 2.5. So we're going to start with the b, so negative 2.5, 1, 2.5. Then I need to go up 1, so that's going to be a 1, negative 1 and 1/2, and then over 2. Up 1 over 2. Up 1 over 2, all the way across the graph. Up 1 over 2. So down 1 over 2. Okay, so I'm going to connect my points, and this one is solid, so I can just connect them all. And I'm going to test that 0, 0, because again, it doesn't fall on our line. So I'm going to plug it into the equation. You can either plug it into this one or the one that you solved for. It doesn't really matter. I'm just going to plug it into this one. Like I said, it doesn't matter though. So this is my x and this is my y. So I'm plugging it in here. So 0 is less than or equal to 1/2 times 0 minus 2.5. So anything times 0 is just 0, so that's going to cancel. So 0 is greater than or equal to negative 2.5. So 0 is bigger than negative 2.5, so this is true. So this time we're going to shade to cover the point. So we're going to shade above because the point is above. Okay, we are done with the note packet. So let me know if you have any questions, and otherwise I will talk to you later.